Hello, everyone. I'm back with another ACT question. Now, remember, as always, like and subscribe to the channel so that as I drop these questions, you'll be notified so you can go ahead and receive these questions. Now, for this one, this is a really good time for you to go ahead and pause and then try the problem on your own and see if you get the correct answer. So for this one right here, guys, we're getting right into it. For what value of A would the following system of equations have an infinite number of solutions? Now, when a problem, a system of equation has an infinite number of solutions, guys, we say another way to express that is to say that it has all real solutions. Now, let me mention a couple of things. When they're talking about systems of equations, there could be three different types of solutions. There could be one solution where when you graph the lines, the two lines, guys, they intersect at one single point. So that would be X comma Y. Whatever that point of intersection would be the solution, okay? And by the way, there's various ways to solve systems of equations. There could also be no solutions. That's why you try to solve the problem and everything cancels out. You end up with a statement that makes no sense, okay? By the way, when a system has one solution, we call it independent. And when it has no solution, we call it inconsistent, okay? Now, inconsistent means it has no solution, okay? Now, let me get to my point. When it has an infinite number of solutions or all real solutions, for this one, we call it an identity, all real solutions. Now, think about what this means, guys. All real solutions. If a system has all real solutions, we call it an identity. Okay, so if it's an identity, the problems, the two equations must be identical to each other. So that whatever you plug into the first equation, you would plug in the exact same thing in the second equation, so it would make both equations true. So guys, for your problem right here, let's look at it. Let's analyze it. I am going to go ahead and rewrite the problem over here again. All right. And so I want you to analyze that first equation and compare it to the second equation, guys. Okay. Look at it. Take a moment. Look at it. And this is A. Our job is to find the value of A, guys. Okay. What is happening, guys, from to equation A or equation number one here? Let me number them for you. Number one and number two. What are they doing to equation number one in order to get to equation number two? Listen to that question again. All right. So the question is simply this. You're supposed to be asking yourself this question. Okay. This is called the brainstorming portion of this. Okay. So the question is, how did they go from the first equation to the second equation? Because you want both equations to be identical to each other. You want them to be the exact same thing. So if you want the first equation to be the exact same thing as the second one, to go from 2 to 10, you would have to multiply the 2 by 5. To go from negative y, or in this case, a negative 1, remember, guys, when you have a variable that doesn't seem like it has a coefficient, the coefficient is negative 1. So how do you go from negative 1 to a negative 5? You'd multiply it by 5 as well. So what's the pattern? It looks like every single term in the first equation is being multiplied by negative 1. So if that is the case, guys, we would multiply the first equation by 5, okay? So 5 times 2x would give us a 10x. That's good. 5 times negative 1y would give us a negative 5y. That's perfect. Now, let's get to the part we're trying to solve. So here, if we multiply 5 times 8, we're supposed to get 40. But guys, where the 40 should go, we have a 4a. So there's your little equation. And then you go ahead and solve this. So you can figure out the solution. Now we're going to divide both sides. Oops, I put too much here. Let me go ahead and clear this out, guys, because that's looking a little messy here. And I don't like it when it looks messy on here. I want everything to be very clear. So we divide both sides by 4, everybody. And just like that, you get A is equal to 10. Now, guys, there's your answer right there for this one. It's going to be a letter G. And just like that, we are done. This one wasn't too bad. But guys, remember, when you're taking these standardized tests, the majority of the time, It's all about critical thinking. What are you thinking about these problems? How are you thinking about them? We call that metacognition, thinking about thinking. So, guys, good luck. Remember to bring a calculator and do well on this test.